It's just a video presentation on simplifying radicals by Mathematically Marcia. Okay, let's talk about, first of all, what a square root symbol is. And a square root symbol means we're looking for the number that multiplied by itself equals that number. So for this one, we could read that radical 36 or square root of 36. Because 6 times 6 equals 36, the square root of 36 is 6. Now, square root of 24. This is not a perfect square. You could take a calculator, punch in square root of 24, get a rounded answer, but this is irrational, so it would not be an exact answer. So what we're going to do is we're going to simplify it. So it will still be exact, but we'll pull out as many roots as we can. So let's do that, first of all, by defining the prime factors of 24. So I like to use what I call the upside down division to do it. And we divide by a prime factor. I always start with 2 if we can. So 2 goes into 24 12 times. And then I can divide by 2 again. It goes 6 times. I can divide by 2 again. It goes 3 times. 3 is prime, so I know I'm done. Now I look for pairs of the same number. Right here I have a pair of 2's. So that means a 2 gets to come out of the radical. And then everything that's left, we multiply together. So you have a 2 times 3 left, which is 6. So that goes inside the radical. Now, if you want to check it, you can square the outside number and multiply the inside numbers, and it should get you 24. So 2 squared is 4, times 6 is 24, so that checks. Okay, and another way to look at it is to look for perfect squares that are factors of 24. For example, 4 is a perfect square because 2 times 2 is 4. And then, of course, to get 24, I would need to do 4 times 6. And then the square root of 4 is 2, radical 6. So when we do the prime factors, that's basically what we're doing, is we're finding those perfect squares by breaking it down and looking at the factors of those perfect squares. Okay, here is a radical that includes some variables. So let's look at how to do this. We'll start with the number portion, 32. Let's do the prime factors again. So 2 times 16, 2 times 8, 2 times 4, 2 times 2. Now look for the pairs. We have some 2's here, and we have another pair of 2's. Then we have that 2 left outside. So we come to a radical outside, we have 2 sets of 2. On the inside, we have a 2. Now I left some space because we need to do the variables. And there's a couple different ways that you can think about this. The way that takes the most writing is to write the exponents out in expanded form. That way you can easily see what you've got. You're breaking these down just like we broke the numbers down. And then you circle the pairs just like you did with the numbers. So when X comes out, a Z comes out because there's a pair of those. And then we have an X and a Y that did not get circled. Another way to look at it with the numbers is to divide. X cubed, so which means you have 3 x's, so do 3 divided by 2. This will help you figure out how many pairs there are. So if 2 goes into 3 one time, which means there's one pair that comes out. And then you have one remainder, which is the one that stays inside. And then with the y, you only have one. That's not enough to make a pair. So just leave the y inside. And then z squared is 2. So 2 goes into 2 one time. And there's no remainder. So 1 comes out, and there aren't any left inside. So this way, if you have really big exponents, this is probably a better way to go. Expanding it is a good way to visualize and see where your pairs are, though. Okay, now in this one we have a different index. Now instead of looking for groups of 2 or pairs, I'm going to look for groups of 3 because my index is a 3. Still going to start by finding the prime factors. I can divide by 2, gives me 8, and then divide by 2 again, then divide by 2 again, and I have a 2, so I know I'm finished. And now instead of looking for groups of 2, I look for groups of 3. There's 3 2's right there. So I have one group of 2's that comes out, and I have one left over that stays inside. And then our index remains the same. We're not going to change that. So 2 cubed root of 2 is how we would read that. Okay, now we have the fourth root of 32 x to the 6th y cubed. Once again, we're going to find the prime factors, but we're looking for groups of 4 this time because my index is right here is my index, and it is a 4. So let's do the prime factors of 32. We can divide by 2 times 16, 2 times 8, 2 times 4, 2 times 2. Now I'm looking for a group of 4. So one group comes out, and I have one left over that stays inside. Alright, so far we have a 2 outside and a 2 inside. I left a space so that we could do our letters. Now I'm going to go ahead and expand it so that we can again visualize. But if you were to divide, you make sure you're dividing by 4, not 2, since 4 is your index. So we have 6 x's, and we have 3 y's. So I'm looking for groups of 4. I see 4 x's there. There aren't enough y's to make a group of 4. So we have 1 x that comes out, and I have 2 x's left over, and I have 3 y's left over. And then of course I need to keep my index of 4. We're not going to change that. So we have 2x, and then the fourth root of 2x squared y cubed. Okay, let's do the prime factors of 32 again. I'm getting good practice with some of these numbers. So 2 goes into 32 16 times. 2 goes into 16 8 times. 2 goes into 8 4 times. 2 goes into 4 2 times. Now my index is 5, so I'm looking for a group of 5, and I have 1 2 3 4 5 2's right there. So all of my 2's, they make one group, so I'll bring a group out of 2 out. And then the y's, we have 1 2 3 4 5, which is a group of 5. So y comes out. Notice everything was in the group. I didn't have any leftovers, which means I don't have a radical left in my answer. That was actually one that we were able to completely solve. So the fifth root of 32y to the 5th is 2y. And again, you don't always necessarily have a radical in your answer. Only when you have extras do you need a radical in your answer. Alright, let's look at one more example. Let's do 128 x to the fourth y, or a cubed root of 128 x to the fourth y. So let's start by finding the prime factors of 128. Divide by 2, get 64. Divide by 2 again, get 32. Divide by 2 again, get 16. Divide by 2 again, we get 8. Divide by 2 again, you get 4. Divide by 2 again, you get 2. Now our index is 3, so we are looking for groups of 3. So I have 2 groups of 2. So I'll bring 2 2's outside. And I have 1 2 inside. And I'm leaving space for the variables, which we have x, 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 y. And we have a group of 3 x's with no leftovers. So when x comes out, I do have an extra y that stays in. Now, we're not going to leave this 2 times 2 outside. Go ahead and multiply that. So 4x, we do need our 3 here, and then cubed root of 2y. If you have any questions, comments, or requests for future videos, please comment below and share. You can subscribe to my channel to see more videos like this. And thank you for watching.